Good morning, good afternoon, good evening, class. It's Mr. Arocena, and on today's video we're going to be talking about the electrolysis of compounds. So this is kind of what happens when you get a redox reaction that has a negative voltage. You end up creating what's known as an electrolytic cell. So electrolysis, by definition, is the act of supplying electrical energy to a compound so that you can create a chemical change in the compound. Usually this will involve the breaking of the compound, so that's hence the term electrolysis. So basically lysis means to break, and this is to break with electricity. So when you supply electricity to an ionic compound, you can cause it to separate into different ions. And this will usually occur in what is known as an electrolytic cell or an electrolysis cell. Okay? And these are very similar to electrochemical cells. The only difference is that the electrolytic cell will generally have a negative voltage, meaning that the reaction doesn't occur naturally. You have to supply electricity. So here's an example of a simple electrolysis cell involving sodium chloride. And what will happen is that if I connect this to a battery, I will have two reactions occurring, one at the anode and one at the cathode. At the anode, this will attract the anion. So the anions get attracted to the anode, and they will turn, or they get oxidized at the anode. So in this case, the Cl- ions will get turned into chlorine gas. And you get the oxidation reaction occurring at the anode. At the cathode will attract the positive ions to itself, and here a reduction will occur at the cathode, and this will cause the sodium ions to become solid sodium. So at the anode, oxidation will occur. So very similar to an electrochemical cell where the anode is the oxidation. At the cathode, the reduction will occur. Again, very similar to the electrochemical cell. So our acronym of an ox-cared still holds true for the electrolytic cell. Oxidation occurs at the anode, reduction occurs at the cathode. Now, for this cell, what's the voltage? What is the E cell this reaction? Recall that to calculate the overall cell voltage, we just take the reduction cell voltage and add it to the oxidation cell voltage. So my oxidation is the chlorine ions becoming chlorine gas. They're losing their electrons. That's my oxidation. The reduction is the sodium ions gaining electrons to become solid sodium. Now these will have the following voltages. So my oxidation will have a voltage of negative 1.36 volts, whereas the sodium reduction will have a voltage of negative 2.71 volts. So the total cell voltage ends up being negative 2.71 volts plus 1.36 volts. So this ends up being a total of negative 3.07 volts. So this reaction is not spontaneous in the least because it requires a substantial amount of energy in order for it to happen. So in this case, the voltage you get from an electrolytic cell tells you not how much voltage the cell creates, but how much the voltage the cell needs in order to operate. So if I supply this particular cell with this much voltage, I can force the chlorine ions to make chlorine gas, and I can force the sodium ions to make solid sodium. It doesn't normally happen in nature, but with a little bit of help from us, we can get this reaction to work. Now, if you have multiple oxidation or reduction reactions possible, much like the preferred electrolytic or electrochemical reactions, there will be a preferred reaction that will occur in the electrolytic cell. And this will happen between the pair of substances that require the least voltage input. In most cases, this will mean the strongest oxidizing agent and the strongest reducing agent. So very similar to how a normal preferred redox reaction takes place between the strongest oxidizing agent and the strongest reducing agent. In an electrolytic reaction, the same thing is also true. Because usually the strongest oxidizing agents and the strongest reducing agents will be closest together and therefore have the least amount of voltage necessary to occur. Now there will be some things to consider, especially with aqueous solutions. So if you have an aqueous solution, if it's neutral, you have to consider that water could be one of the oxidizing agents or one of the reducing agents. So you need to consider that as a reduction agent or as a reducing agent, this could be one of the possible reactions. So one of the possible reactions. Because being aqueous means that water is present. And similarly, you also have to consider that the reduction of water might also be present. And this is again because in aqueous solution you will have some water present, and depending on what else is in the solution, water might actually be the strongest oxidizing agent or the strongest reducing agent. In an acidic solution, you have to consider again, because acid solutions tend to have water in them, actually they all have water in them. An acidic solution, an acidic situation, you have to consider the oxidation of water again. And because acidic solutions tend to have large amounts of hydrogen present, you have to consider the reduction of hydrogen. Now, hydrogen ions can't be oxidized, so you don't have to worry. Hydrogen ions can't be oxidized because they have no more electrons to really give away. So, but they can be reduced. So for acidic solutions, this has to be one of the possible reactions, and also this has to be one of the possible reactions. Now there's a couple more exceptions in that chlorine and bromine, for whatever reason, if you have chlorine ions and bromine ions present, they will always undergo oxidation, regardless of whatever is present in the solution. And I've run into this several times where I tried to use sodium chloride as an electrolyte, and I would always end up producing small amounts of chlorine gas instead of the thing that I actually wanted to oxidize. So chlorine and bromine, because of the nature of the elements, they will get preferentially oxidized, as opposed to other things that might be stronger oxidizing agents or stronger reducing agents. They will defer to the chlorine minus, and the chlorine minus will get oxidized before anything else does. Let's go through an example of how to figure out what happens in an electrolytic cell. So here in this example, we are forcing electricity through some electrodes, and the solution contains nickel sulfate, and make note it's aqueous, so water is present. It asks us, what are all the things present? Well, the nickel sulfate will break down into nickel 2+ ions, and it'll break down into sulfate ions, and because water is present, there will be some water in the reaction chamber as well. Now, once we list out the species involved, we can then move to write down whether the conditions are neutral or acidic. We've already established that the conditions are neutral. So we know that water must be present. And now we guys have figured out what is the strongest oxidizing agent and what is the strongest reducing agent. Well, we have nickel 2+. This can undergo a reaction to gain electrons to become nickel. We've got SO4 2-, which when this undergoes a reaction, this will actually give up electrons. SO4 2- will give up electrons to become S2O8. 2 minus. There we go. That's the other reaction. And then finally, water. Water has two different reactions. There is the oxidation of water. So this is where the water will turn into H plus 2 electrons, and then, sorry, we need 2 of these, plus O2. Or water could be a reducing agent, and water could be an oxidizing agent, which will give this reaction. So water as an oxidizing agent will form the following. Okay, so now we just decide which is the strongest oxidizing agent and what's the strongest reducing agent. Well, of our oxidizing agents, we have nickel 2 plus as an oxidizing agent. And the other oxidizing agent we have is this water down here. Okay. This water here is acting as a reducing agent because it's getting oxidized, so it's a reducing agent. And this substance here is also a reducing agent because it's given. Alright, so which ones are the strongest oxidizing agent and strongest reducing agent? According to our table, this is our strongest oxidizing agent. And this is our this one's our strongest reducing agent. So these will be the reactions that will occur. And then we can calculate the voltage for that. So here's my reduction voltage is going to be negative 0.26 volts, and my oxidation voltage is going to be negative 0.82 volts. So the total cell voltage for this will be the negative 0.26 plus negative 0.82 for a total voltage of negative 1.08. There we go. So this cell, in order for this to work, would require a voltage input of at least negative 1.08 volts. Okay, let's go through another example. Here we're going to take we're going to try and electrolyze a 1 molar solution of hydrochloric acid using inert electrodes. The inert electrodes mean that the electrodes don't actually act. And we'll go through the same process. So if you want to try this out on your own, feel free to do that, and then I'll work through it in a moment. Alright, so the first step, we're going to list all the species present. As before, you've got H plus and Cl minus. Then from there, we'll check the conditions if it's neutral or acidic. In this case, because of H plus, it's going to be acidic, but there's also water present because it's acidic. And then the last step, we'll list all the oxidizing agents and all the reducing agents and decide which one is the strongest. So of our things that could get oxidized, the oxidizing substances, we have chlorine. So chlorine ions can get oxidized to make chlorine gas and electrons. And then water can be oxidized as well to create there should be 2 of those. Create 4 H pluses plus an O2, and then 2 electrons. Actually 4 electrons, not 2. 4 electrons. These are my oxidizing agents. So oxidizing agent. My reducing agents, well, there's really only, I'll list both. There's the H plus. H plus will require 2 H pluses plus electrons to become H2. And water could also be reduced as follows. H2 plus H minus. There we go. So here are my reducing agents. Now we just decide which one's the strongest oxidizing agent, which one's the strongest reducing agent. In this case, this is my strongest oxidizing agent. Well, that wouldn't matter because chlorine minus will always be Oops, I think I have that backwards. So this is actually a reducing agent. These are my reducing agents. This is my oxidizing agent. Sorry. Alright, so because the Cl minus is present, that'll always be preferentially oxidized, so this will always be the reduction reaction if Cl minus is present. And then the oxidizing agents, the strongest oxidizing agent we have is this one here. So this would be these would be the reactions that would occur. The Cl minus would become chlorine gas, and then the H plus would become hydrogen gas. And you can calculate the cell voltage again. So here we have so this is an oxidation reaction. So the oxidation reaction voltage would be negative 1.36 volts. And the reduction reaction voltage here would be 0. So my total cell voltage would be negative 1.36 volts. So the process is very similar to an electrochemical cell. The only real difference is that your cell voltages will always be negative for an electrolytic cell. It basically just means that you have to supply energy to the cell in order for it to operate. So now to recap the differences between electrochemical cells and the electrolytic cells, we'll just go through a few key points between them. So in an electrochemical cell, these things will produce voltages. So they have positive E cell. So E cell is positive. And the preferred reaction will be the strongest oxidizing agent with the strongest reducing agent. In an electrolytic cell, these ones will require voltages because they will have a cell voltage negative, and the preferred reaction will always be the pair that requires the least voltage input, except in cases involving Cl and Br, because then these will always act as reducing agents. Even though they're very weak reducing agents, according to our chart, because of their nature, they will always be the reducing agents, so they'll always be the ones wanting to be oxidized. Okay. Alright, your assignment then for this section is as follows. If you guys have any questions, you know how to contact me.